Hello, students. Mr. Murphy here. So, lesson 8 is kind of where we are, but not really. We're moving on in weird orders. But we're going to talk about scientific notation. What is it? So, let's take a look at that first. So, scientific notation is a positive finite decimal, as said to be written in scientific notation if it is expressed as a product d times 10 to the n, where d is a finite decimal, so that 1 is less than or equal to d, which is less than 10, and n is an integer. The integer is called the magnitude. So we just learned that. D, so we have a number times 10 to a power, and that power is the magnitude of the number. So let me put it in English. Basically, really big or really small numbers, we move the decimal until we have a number in the ones place. And then we give us a power of 10 for every spot we move that decimal. If we moved it to the left, it would be a positive power of 10. If we move it to the right, it would be a negative power of 10. Okay. Let's try a couple to see how it goes. So I've got this really big number. The decimal for this number would be right here after the 5. So if I move it, I'm going to move it until I get it right here, right between the 5 and the 6. And I just have to count my decimal places, and that's my exponent. So powers of 3, 3, 6, 9, 12, 13, 14. So this number would be 5.68 times 10 to the 14th. You're saying, wait, Mr. Murphy, what about all these other numbers? Well, if I'm going to shorten this, Andy, I've got to get rid of those numbers. So I'm going to round this. Scientific notation is usually rounded to 1 or 2 decimal points. Some people argue on that. We're going to go with 2. So this number, decimal, I'm going to grab 5.67. And now you're saying, wait, Mr. Murphy, that's a 7, not an 8. Well, this is an 8. This is a number that's 5 or bigger. So I'm going to round this up to 8. So 5.68 times 10 to the 14th power is the scientific notation for this number. This number, 0.00000004581, I'm going to take this decimal point, thank you for putting it there for me, and I'm going to move it just past the 4. So that 4 is a number between 1 and 10. How many spots did I move it? 3, 6, 7, 8 spots. So this is 4.58 times 10 to the negative 8. Notice, I dropped the 1 because I'm only keeping 2 decimal places. The 8 stays as an 8 because the 1 here is a number less than 5. So I have 4.58 times 10 to the negative 8 is the scientific notation for this number. All right. So which numbers are in scientific notation? 3 times 10 to the 58. Yes, 3 is between 1 and 10, and I've got power of magnitude. 4.789 times 10 to the 6th. No, it's only 2 decimal places, but some people might say yes. So be careful on that one. 0.23 times 10 to the negative 5th. No, because 0.23 is smaller than 1. 2.3 times 10 to the 4th. Yes, because 2.3 is between 1 and 10. Notice these two are actually the same number. This is scientific notation. This one is not. And our original number, 25 trillion, 25 times 10 to the 12th, is not in scientific notation because 25 is larger than 10. I can move the decimal point 1 spot over and be 2.5 times 10 to the 13th. Okay? All right. So now we know how to get numbers in scientific notation and what are scientific notation. So to be consistent, we use exponential notation for very big and very small numbers. We use scientific notation actually, and there's a couple of rules. So to create scientific notation, count the digits left or right from the existing decimal point. The number of digits counted becomes the exponent, our magnitude, with a base of 10. Count left and the exponent is positive, count right and it is negative. and the magnet or that number that's left has to be between 1 and 10 with less than 2 decimal places. Okay.